Uh, my computer updated again the other night, and as a result, the pen doesn't work again. As I said, my suspicion is that there's a bug in Windows 10, and that's why the pen doesn't work sometimes, and sometimes it doesn't. They fix it, and then an update comes out, and then they break it. So, and you'll figure that out when you start working if you do any programming, that if you got multiple programmers and there's been a fix to a bug and not everybody gets the fix in their system or in their code, they end up breaking it again. Another reason to keep a common set of libraries. I don't know why Microsoft has these problems, but okay. Right there. All right. Okay, I think I started this chapter. It was before the test, and I gave you last Tuesday off that there. So, but I'm going to go ahead and restart chapter 5 that there, and kind of go through. And what chapter 5 is getting into is probably one of the more important chapters when you look at not just programming but engineering. That there, and we're going to be creating functions now. If you're doing engineering work, you might be building subsystems or modules or things like that. But the first thing that the author says is most computer programs that solve real-world problems are much larger than the programs presented. In other words, you know, your midterm was about 10 lines long. You know, before I broke my version that there, and I haven't had time to go back and fix it, but actually still the fixed version it's about 10 lines long, and a couple of them that I saw working were about 8 or 9 lines long, something like that, 10 lines long. Somebody had a little bit more than that, but most programs that are in the real world that do something significant are not 1 page long. Up there. Several of the projects I worked with, we had 300-400 pages of code. Up there. So, these are relatively large programs up there. So, and in order to make it work, we need to break it up into smaller pieces, right there. If you're going to design an automobile, you don't sit down with a CAD program and design the entire system at one time. Somebody would design the engine, and even designing an engine by itself is too big of a job. One person would probably design the fuel intake system. Another person would probably design how the cylinders work. Another person would design the camshaft. That there. So, the engine would be broke down. The block would be another design. That there. But each component is designed separately. Maybe by another individual people, or maybe by one person doing it one component at a time. That there. If you want to build an electrical power plant, you probably have many engineers that subdivide the project. That there. And an electric power plant, of course, you're probably buying the generators from a company like General Electric or Siemens or someone like that. You're buying the wiring from someone, the switch panels you're buying from someone. But again, you still have to break it up into pieces. That there. One person is probably responsible for the building. One's responsible for determining how we're going to put the switch panels in. One person's going to be in charge of how, getting the generators placed in place, and he may have 20 people working for them there. So it's called divide and conquer. That there. So you essentially there, and the same thing is true with something like operating a university like UniKL. You have the president of UniKL at the top, and he probably has no idea what the cleaning lady does. That's there. Even though the cleaning lady works for him, but she works through probably 10 different levels of management right there. So when we look at, managing an organization, we typically have a divide and conquer. Eon Big, for example, or Eon, the regular Eon stores right there, or I guess it's, the old giant Jescos or eons. But even then, they have store managers, they have shift managers. So again, we're looking at it. Well, the way that we break things up in C is we write functions right there. Now, you can either use functions from the prepackaged library, or we can write our own. Now, we've been using prepackaged ones right there. So, again, I know that I've gone through these slides, but I'm going to point up there. So, familiar yourself with the rich collection of functions in C. A good C programmer with experience probably can cite off most of the functions in the math library and the string library and that there. I haven't wrote any large C programs in a few years, so I probably would have to look them up in a book that there, or a manual that there, use help. But you have to realize that there's functions for everything that there, and they're in the library. Not everything, but there's a good number of them that's there. And again, avoid reinventing the wheel. I used to require students that do certain things in the class, and then someone else that there says, well, there's a C function that, or a function in Visual Basic that does that. I was teaching Visual Basic, and I said, yeah, but I want to teach the students what's in the function. So sometimes as an instructor, you might make students write things that there's a function in the library that does that. But but you're trying to teach the concepts that are in the function. But generally, you should use functions that are in the library whenever possible, because they're, if they're in the C library, chances are that they've been tested and they work. I've given a couple of examples, or at least one example, where a function didn't work properly. But typically, if it's in the library, it's been tested, and you can almost, with 99% certainty, it's going to give you the right answer every time. So, using functions in the C library that's not necessarily true, because not all functions are in all libraries. If you're writing stuff for desktop applications, scanf and printf are in the library, right? Well, printf and scanf may not be in a library for the 8051 microcontroller for an embedded system. So if you've got scanf and printf, you have to write those functions. That there. So, okay. These are some examples right there. And, out there. Programmer defined functions, but the functions, we write our own functions. Right there is what we're saying. That there. You can use the standard library functions whenever possible, but sometimes there's not a function in place right there. So they go through the whole discussion I talked about earlier about the calling function as worker to perform a task and report back when it's done. I know I've talked about that before. The worker may call other functions, so a store manager might have cashiers that work for them. There may be a cashier manager. I follow American football, which I realize is kind of a people here don't follow American football. It's something that we call soccer, right? But when we look at American football, that's there. We might have, here's our football team. Right there. Let me put this there. There's a head coach. Right there. Then under him, there might be an offensive coach, a defensive coach. Under the defensive coach, there may be a linebacker. Right there. There might be we'll call it a defensive end. But but there's different coaches underneath the head coach. Now, if you're at your school football team, you may only have one coach, right? But if you look at a large football organization, there might be 20 coaches. And if you look at the offensive, there might be a quarterback coach. and he only coaches 2 or 3 people. The average American football team has one starting quarterback and 1 or 2 backups. So there may only be 2 or 3 people underneath that he coaches. There may be a coach there that coaches the wide receivers, a running back coach right there. The running back is the guy they hand the ball to and he tries to run with it. A wide receiver is the guy who they try to throw the pass to. There might be a tight end coach. So the offensive coordinator, he's not called a coach, he's called the coordinator. Offensive coordinator may have 4 or 5 coaches under him right there. And each one of those has a job to do. And that's the whole idea of, a worker may call other workers and the boss may not be aware of it. Now, chances are, if you're talking about an organization like a football team or a university or a corporation that owns a number of department stores or grocery stores, the boss usually is aware of the fact that they have cleaning ladies that work for the university, right? I'm sure the president of the university is well aware that this campus might have 4 or 5 women that go around and clean sweep the floors and empty the trash. But the president of the university doesn't want to get involved in assigning the duties to that person. That person is given their duties by, somebody from the university, the individual campus. There might, I don't know who it is in charge. But again, there's several that there. So they show that as here we got the boss, worker 1, and worker 1 got worker 3, 4, and 5 reporting to him right there. And again, that's the same thing that happens with functions right there. A function may call another function right there. So I'm going to kind of skip over the math libraries because we've already talked about them in great detail. You use power for that there. Square root's another one. Printf, of course, up there. So again, up there. Here's a list of some of them right there. Square root, cube root, exponential e to the x, the log with base e, log with base 10, the absolute value of a floating point number, that's there, the ceiling, the smallest integer, the floor, the power. I mean, these are all, that's a very small set of functions in the C library right there. So, okay, functions allow you, and this is probably, I think that's where I stopped last time. That's there. So, variables defined in a function are local variables. That's there. You'll hear the term local versus global variables. Now, where that comes into play is at the top of my program, I have my includes, and I'm not going to list them, but there may be standard io.h, standard library.h, math.h, string.h, there's a whole bunch of that there. Then we have our function headers, and we'll talk about them in a section. Headers, right there. And of course, the includes are actually nothing but a bunch of function headers, actually, that's there. And then we might have a section here for global variables. Now, global variables are variables that are defined outside of any function, and any function in your program can access them. They're global, they're known throughout. And we may also have some constants right there. So global variables and constants. And when we talk about constants, that's something like GST rate. That's fixed right now at 6%, right? So if you're writing a software program that's going to work for a food stall and you want to charge GST to report like the law says you're supposed to, that there, we won't discuss whether or not they all do that, but if you write a program for a small restaurant or stall that is collecting GST and paying the GST, you would have to include GST rate as a constant. And you would normally put that at the top of your program. And you would call it a constant. And the reason you would call it a constant and put it at the top of the program is what happens after the election. The GST rate goes to 4%. Another party takes over. Or another party takes over and changes to 7%. Or the same party stays in power and raises GST rate to 7%. I think Singapore's GST rate is going to 9%. That's what I got there. So GST rates are not fixed in concrete as a general rule, right there. They can change given the political climate. I'm an American, and I have some U.S. income that I have to declare and do taxes on, and the tax rates recently changed. President Trump or Rump or whatever we want to call him, the resident clown of Washington, I can pick on the U.S. president. Since I voted against him, But regardless, I don't think we've ever had a president this bad in my lifetime, to be honest with you. I'm sorry to say that, but I just don't think we've ever. I don't remember, and I was around when Nixon was president, and so Trump is by far the worst president I've ever imagined. But regardless. The one thing he did do is they changed the tax laws in the U.S. So all the tax software people or tax software companies, and there's a lot of them, Tax Cut, TurboTax, H&R Block. There's companies that generate software to help you fill out your taxes. So the tax laws have been fairly consistent. 2018. That they completely changed the tax laws. So all that software has to be rewritten, and a lot of those constants have to change right there. It just so happens that in my case, the tax laws worked in my favor, the changes. But again, tax laws change So when you have software and those are constants. Then you normally have main, right there. And then after main, we start our functions right there. So our functions are after our main program, right there. So as you're reading your code, the functions would be in your main code, right there. Now, it is possible that your functions could be in another file even, out there. So, okay, now we can declare variables within functions. Those are called local variables. I mentioned the fact that we have global variables and we have constants that are known with that there. Now, it's considered a bad programming technique to use global variables. So this particular book doesn't talk about global variables. I'll mention that they exist, and there are situations where you would use global variables. But they're usually in the embedded world, that they're not so much on desktop. We had a guy that taught C for us back at my old campus, and I was teaching the embedded programming course, the microcontroller course and the advanced microcontroller course. So I was talking about using global variables in such cases, and the students just kind of revolted because they were taught never use global variables. So me and the guy who taught the freshman or the sophomore level C course, we had one of those little powwows and said, all right, show me how I can do this without a global variable. You're the expert in C. He worked for Raytheon, so he was an industry person. He said, no, our embedded people always use global variables. So he admits that there. But this particular author doesn't work in the embedded world, so he won't talk about that. So we also have parameters, and I keep wanting to use this pen. I can't use it on that there. But parameters are ways that we communicate stuff to our functions. right there. So up there. And we've already used parameters when we pass information to our functions. Because when we use the power function, which most of you use it right for part of the midterm, but when we use the power function, we had to pass it 2 numbers, right? When we use printf, we have to pass some numbers to it. When we use scanf, we have to pass an address to it. That's it. So that's it. So, but several motivations is kind of a list. I'll just kind of go through the points real fast. We've already talked about divide and conquer. The other is software reusability. I've kind of pointed this out earlier when I talked about GE and their software library right there. Object-oriented programming, which we won't be doing in this class. That's there. But again, that's software reusability. And again, they talk about that. The third motivation, there's really 3. 1 is divide and conquer, 2 is software reusability. The third is to avoid repeating code. When you write a function, that code resides one time in your code, and everything happens. And what happens, and I'm not going to necessarily get through all these slides, is you're going through and you're running code, and you see a function call right there. You know, and I'm just going to put a dot saying we pass some parameters right there. Right there. What happens in C, in the computer system, as it's executing your code, is it hits this function that there, and it leaves, and it runs the function right there. It runs that code. It hits either the end of the function or it hits the return right there, and then it goes back and starts executing the code. But this function right here is only included in your code one time. And every time I call it, I execute the code, and then I go back to the calling routine. That's there. So that's there. So again, that's there. So a function should be limited to one defined task. That there. If you can't come up with a name to define what a function does, you're probably doing more than one thing. And I think I mentioned this earlier, right there. Each function program with it there. Main is a function, right there. It receives a variable, and there are functions that are written. You don't see them so much anymore, right there. But there used to be a function called like file copy. And I'll say test.doc, and I'll say /test/test1 .doc right there. Now, this is a name of a program that's stored somewhere in DOS. Now, this is an old DOS command right there. So, and what it did is it received 2 arguments. One is the source file name and the destination file. Now, what this did is it took a copy of test.doc, and it copied it in the preceding directory under a directory called test, and it called this test1.doc. I meant to put a 1.doc there. So, but this particular program received 2 variables from the operating system right there. So main, in some cases, can receive variables. It's done very seldom today because we have Windows that's there, and we don't necessarily call things from the command line. But you could do command still. You know, you can bring up Windows. Yeah, maybe. Right there, there's a run CMD, and I can do DOS commands from there, right there. So, right there. So back in the old DOS world where we worked in that, it was very common to have things pass the main, because we would do that from the command line. It's not so common today out there. So, so again, we're looking here at the fact that here's an example right here, and I know I covered this before the exam, but then we missed the class, and then we had the exam, so it's been a while. But here we have a function called square, and this is a user-defined function. So we put in a function prototype for it. Function prototype I also call a header, right there, right there. And the function is down here. Now you'll notice that the function prototype and the function definition header, or the first line, are really the same line. Now this y here doesn't have to be there. Now the function prototype only needs to list what variables, what types it's going to receive. It doesn't need to know the names, but typically what most people do is they write the function they write the function definition and they copy and paste that line that's there. So here we printf, which again is that there, we're going to print out the square of x. Now the square of x is not defined here. I could put in y times y, or x times x, right there. But instead, I'm going to go from here and run this function, and this function has just one line where it returns y times y. Also note that x becomes y when it's in the function, right there. So when I call this function with x, but when I get into the function, it receives a single variable, it's an integer, and it's going to be called y within the function. It's a good idea to change the names as you call the functions out there. Now, x in this particular case is defined is not defined here, and we don't declare any variables because the only variable we have is y. So there are no global and local variables here out there. So this just kind of goes through that there. Right there. So the return, now you don't have to have a return. There's another way of doing that there. You could, my function could be, this is int square. There's another way of doing it, int y. And I could do a square equals y times y, and then close the bracket right there. And what that does is, by using the name of the function and assigning it the value of y times y, when it does the return, it knows what to return right there. So, and I could put a return line in here and just put nothing after the return line because I've already defined what square is. It's y times y. So the only reason I point that out is the way he does is probably best. It's least confusing, but you'll run across code that does it the other way right there. So the return value is the type recalled right there. If you have a return value of void, it doesn't return anything right there. So together with it right there, sometimes called the function header right there. So the parameter list is a comma separated list that defines what the function is going to receive. A type must be listed for each one. Again, I know that I covered this before. So then the function body is within the braces. Variables declared within the function can be declared within a block, and the blocks can be nested. I could have a function within a function. We won't do that. But I could have a function that has an internal function. I have done that many times right there. So, okay. So, yeah, now he just says defining a function within another function is a syntax error. So I guess you can't do it with that there. I've done it before with different versions of, maybe it wasn't C up there, but you could up there. We're not going to do it anyway, so don't get in the habit of doing it. It's complex, but I have done it on a couple of cases. Choosing meaningful names. Small functions provide user readability. Should be written as a collection of small functions. Makes programs. You know, the whole idea is that when you write a function and it does one thing and one thing only, you can troubleshoot it and make sure it does its job correctly. That's there. So function prototypes, function headers, and function call, that there. So the prototype, which is what he calls what's at the top of the program, the first line of the function definition or the function header, and the calls all have to match right there. So if I write a function that at there, let's say I write a function here, you know, let's say int, and I'm going to call it just XYZ right there, and it's going to receive int X, int Y, and int Z right there. That's my function header. Blah, 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 blah. Down here is my function int X, Y, Z, int X, int Y, int Z. Here's my function right here. That's inside braces right there. And then somewhere up here, I do, and I'm just going to say K is equal to X, Y, Z, and I say 1, 2 right there. That's an error. The reason it's an error is that here I've got 3 variables right there. Here I've only got 2 right there. There's just 2 variables right there. Now also notice that I put 1 and 2 there. These don't have to be variables here. These can be, you know, numbers. They can be, as long as you're of the right type right there. So that's there. So you keep that in mind that there. Now if I put a comma 3 here, then that's okay. Now I've got 3 integers that I'm passing to it right there. But they all have to match. This is an integer, 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 integer right there. And there has to be 1, 2, 3, 1, 2, 3. The numbers have to match. If you don't, then you've got an error right there. So, right there. So again, if the function doesn't return the result is simply when the end of the function is reached, it just goes back to the calling function. Or you can put a return without anything to it. Some functions don't have, oh, yeah, we're getting, that's there. Some functions don't return anything. Right there. Some functions don't return anything. Right there. And what am I doing here? Okay. So, again, main has return 0, but we can leave that out right there. Okay. And then, again, this is a function that's written. Another example. Here, a couple of key things here. Again, scanf is a function that's going to receive, in this particular case, now scanf and printf are 2 functions that can receive a variable number of parameters right there. Not all, you know, I just gave you the example where you have to match them up 1 to 1, you know, if I define 3 integers, I have to receive 3 integers. Scanf and printf, and there's a number of functions, can receive a variable number of parameters. So printf, in this particular case, receives 2. It receives the first one is the key one, and same thing with scanf. This tells the function how many variables or parameters are going to follow and what type they are. So this says scanf print %s means that it's going to receive one more parameter and it's going to be of type string. Here we're receiving 3 more parameters and their addresses, and they're of type decimal. That's there. So here we're passing to our function call maximum number 1, 2, and 3. Now maximum is defined as receiving 3 integers, just like I did in my earlier example, right there. And our function maximum that there receives 3, 1, 2, and 3 right there. Now notice that they're named number 1, 2, and 3 here. In the function, they're named x, y, and z. And then we figure out which one's the maximum. We set off and say maximum is equal to x. If y is greater than max, we set max equal to y. And then we say if z is greater than max, then max is equal to z. And we return max right there. So that's our relatively simple function right there. So again, at their early versions didn't that there. So what they're saying is that C does check the prototypes to validate whether or not the function calls match. It used not to. So it's possible to call a function incorrectly. You didn't get a syntax error, you didn't get a warning, but you got the blue screen of death when it ran on your PC. And I remember having some programs that did that there. So that's there. So you just gotta be careful up there. So again, this just kind of repeats what I'm going through here. Right there. In this particular case, function call doesn't match. Here he's saying if it's got void, that doesn't match right there. So here again, the math library square root specifies a double, but we're passing a integer to it. Some conversions are done automatically, some are not. You just got to be careful right there. The function prototype causes compiler to convert a copy of the integer to a double before it goes to the, that's there. So in this particular case, that's perfectly fine. That there. So you could end up with some funny problems if you're not careful. The main thing is if you specify you're going to pass an integer to something and you try to pass a floating point number, the compiler might just truncate it. Now it should give you a warning when you compile that there, but so converting large integer types to small integer types also result in change values. So it may change the value right there. And I'm not gonna, that there are unusual conversion rules that there is, this just kind of gets into the fact, as a general rule, if you're writing your own functions, keep the types the same. But if you're calling math functions, quite often you will pass integers where it's asking for a double, or you'll pass floats where it's asking, that's there. That's perfectly fine. That's there. It's when you get into the long doubles is where you get into, and we won't do that there. And this just kind of lists that there. That there. And this just kind of goes through where if we pass it a floating point, that there it's going to do a long float, that or double it's going to do a long float. This just kind of goes through the that there. I'm not going to get into that there. That's there. if you don't put a prototype at the top, the C software actually will. But what happens is when the compiler compiles and it gets to where you call the function and you haven't defined the function yet, it will generate an error at that point saying that such and such a function is not defined or such and such a variable is not defined. So, as a general rule, you don't want to do that. Now, I remember at one time, before function prototypes became common, you would have all your functions listed, and then main would be at the bottom, right there. And that way, all the functions were declared so that it knew what was there. But you had to be careful, because if this function calls this function, you'll get an error in that function. So you had to really struggle to make sure the orders are correct, and sometimes it's almost impossible to do that. So the function prototype became the mainstay up there. So you end up with warnings or errors depending on the compiler. I'm going to skip the stack right there. I don't want to get into the stack. What the stack is it's a place where the operating system stores temporary variables that are past the functions or between programs. So you push things on the stack and you pop things off the stack. Push things onto the stack, and that's where all the temporary variables are stored. So whenever you pass things to a function in that parameter list, the operating system pushes them onto the stack in order to store them. When we get to the function, we pop it back off the stack right there. So it's kind of a temporary holding place right there. So stacks are last and first out. Just think of them in terms of a stack of plates. The last one you put on the top of the stack of plates is the first one you take off right there. The stack size is limited. So if you call functions if a function calls too deep a function, you might run out of stack space. That's typically not going to happen on a desktop application. It can happen on a embedded problem. And especially if you do something which we call recursion, which I don't think I'll get into recursion. But recursion is a function that calls itself over and over again, right there. And if you call that too deep, the stack can overflow, right there. So, that's there. An important thing for computer science students, you're not computer science students, so we're not going to say that you need to understand the stack in great detail. Now, if you're taking a course in microcontrollers or microprocessors, you normally cover the stack. There's commands in assembly language called push and pop, where you push things onto the stack and pop things off, right there. C does all that in the background for us, right there. So we don't have to worry about writing, pushing things onto the stack and popping them off, right there. C does that for us, but you just have to be aware that if we go too deep, we may overflow the stack, right there. So each function is called, we call their functions, each function must return, so you have to keep track of the return address. So whenever you call in assembly language, the first thing you pop that gets pushed onto the stack is the return address, right there. And then all the parameters that we're going to pass to it. Normally we push things to the stack, do our call, and then we pop things back off right there. So, but that's assembly language. We're not teaching assembly language, so that's why each function finds the information, needs return on the stack up there. So if the stack call is not there, it just goes through the order of the stack. So I'm not going to up there have automatic variables. Again, I'm skipping all this stack stuff because we don't need to know it for this class. So up there. So print A and then square A, again, it's all done internally. We don't worry about that there. So this kind of goes through how the stack works, and I don't care about it. I mean, I won't say I don't care. In C, I don't care about it. One of the reasons for using C is so that we don't have to worry about the stack. So I don't know why this author spent so much time talking about stacks. Whether we've talked about headers, that they're the function prototype, we've already talked about that there. So this is include square.h. This is again, if we put the square function in another file, then we would have to include the header file for that. And these includes. These are the ones that are built into C, right there. And I think I'm looking around the room. Yeah, it's only been 45 minutes. I don't know. It's not time to finish yet. That there. Let me kind of go through. Keep on going here. Right there. Oh, we don't want to delete the recording. Okay, these are some header files that are contained in the library. That there. The important ones is floating point float.h we don't normally use. Math.h we use. Signal.h that there we don't necessarily use too often. And what's going on there? Standard library string. Time we will use. That's there. So there's standard definitions. There's a lot of these different ones out there, and most of them you're not going to use in this class. But the only ones you're going to use is strings, time, standard IO, standard library, and math are about the only ones you'll use right there. Keep in mind that if you include a .h file that's not needed, it's not an error. It's not a problem. That's there. I know some people that just simply in their when they start writing any program, they just include them all. That way they don't have to worry about which ones they need and which ones they don't. That's there. So that's there. Okay, this is the one place that I want to kind of talk about for a few minutes, and then we'll come back and review it. It's this concept of passing arguments. That's there. We can pass arguments two ways. One is by value, in which a copy is made of the variable and sent to the function. The other one is we pass by reference, in which case we don't make a copy of it, but we pass the function the address of where it's contained. Right there. And we've already done this in the calling program. We need to see how we do it within a function. String.h, or not string, scanf, that's there. We pass it the address of our variables. And the way we pass the address is we put the ampersand in front of it. The ampersand means the address of. It's a code word. I've already talked about that. That's just like if I loan you 500 ringgits and you want to pay me back, that there, and you're going to do a bank transfer, you need my account number. You don't need my balance. Right there. So when I do, if somebody asks to borrow some money from me and I agree to say yes, the first thing I'll ask to is, send me your account number, with a WhatsApp or whatever. That's there. And the reason I need the account number is because I need to put it in there. If I want to send a package to your house, I need your address right there. So if you want to change the value of something, you have to pass its reference or its address right there. So there changes to, and if we change the value within our function, if it's passed by value, it doesn't change in the calling routine. So if I did something like this, and I do a y is equal to max, and I'm just going to use max A, B, C right there, right there, and I have int max, and it receives, and I'm not going to copy them all, but it receives that there, and I said, I'm going to say the first one is x right there. and I say X is equal to Y in my subroutine. Well, X is the first value, and that correlates to A in the calling routine, but A doesn't change. I could all these variables that are in the header here, or the function declaration, that they're actually local variables within that function. A copy is made and they're local, right there. So changes to the copy do not affect the original. So I can't change the balance in your checking account if you give me the balance, because you just gave me a copy of the balance. And yeah, I know how much is in your current account. I use the word checking. I'm still at there, but I need to have your account number in order to change the balance right there. So again, we're back to this fact that so when we pass by reference or we pass the address, we're allowed to modify the variable's value right there. So pass by value should be used whenever the function doesn't need to modify. Generally, you try to avoid passing by reference if you don't need to, right there. So, because if you accidentally change a value in a function and you pass its value, it doesn't break the rest of the function, the program. But if you pass by reference and you change it and you make it, there's an error in your function, then it's going to create problems. So C, all arguments are passed by variable. Well, that's not true. But there's chapter 6 are automatically passed by reference for performance reason. Okay. All call arguments are passed by value unless we specify otherwise. That's there, and I was thinking that they got into that there. So here we have another program, and I'm probably going to not necessarily go through this in any great detail. This creates the random number generator, and we're going to generate a random number that's going to produce integers between 1 and 6 right there for die right there. So if you throw a dice, it's got value between 1 and 6, right? And we're going to assume that it's relatively random between those that there. So here we have a function that's going to throw a series of dice right there. So but this is using a function right there. Now, there's a problem with the rand function is that it needs to be randomized each time, and we'll talk about that in a few minutes right there. So if we could throw this is a program that throws the dice 6 million times and determines the frequency of each time right there. So as you can see, it's a relatively even declaration. And I'll leave this program for you to look at. It's actually a pretty good program to use because I actually have assigned, and probably in the final project for this class, the C part, you have to use a random number generator. One of the things I do is, for example, I have you buy a bunch of Happy Meals and collect, toys or something. That's there. So back in the States, I used the same assignment that there. Only I had them collect American football helmets. There's 26 teams, and how many times do I have to go to a dispenser to buy toy football helmets to get all 26 teams if there's a random possibility of getting each of the 26 teams right there. And it is very, very common in engineering simulations that we do random number generations. Random number generations actually is used a lot more than you think in terms of engineering software. So if I'm trying to figure out the average power load in a grid and I know that there's 100,000 households, and then each household is got a power usage that is a random number between such and such. I have to use that to do my simulation. If I want to look at how many queues I need in a bank in order to keep the number of customers in a queue down to 3 people, I have to know the probability of customers coming into the bank. So random number generations, come into play. If I buy resistors, right there. No. For example, what am I doing here? I am just now drawing a blank here. Right there, here's what I'm looking for. But if I buy a resistor, right there, and its value is 110K plus minus 10%, right there. So the resistor value is going to be 10K, 9K, 11K, right there. And it's going to be something like that right there. It's a normal distribution right there. So that's there. So if I'm going to do some kind of simulation software and I'm going to analyze this circuit, I have to take in the case, the worst case of that there, the best case, and the nominal value right there. So I have to look at all the various components there and see what is the circuit going to fail right there. And one of the things we used to have to do at both Magnavox and General Electric, we used to have to put these things in ovens and freezers and test them in real life. And these variables change as temperature changes. So, but getting back to our discussion here, that random number generation is a huge part of engineering software in terms of simulation out there. So here we're looking at and here we're using the random number generator. Randomizing the number that there, and I promise I'll quit after this, is that repeatability is the important factor of the rand function. So we can, the rand function actually creates a pseudo-random. It's not 100% random. There is no such thing in terms of computer program, but it's close enough. There. It repeats itself each time the program is executed, and we can randomize it or create a seed right there, and it's called SRAN, which stands for seed the random number generator. And we can either pass at a known number, so we get the same sequence every time, or we can pass it a semi-random number. And right there. So right there. So the random numbers generator seed here is, we seed this right here. And we can generate a known seed right there. So here it says enter the seed and see the random number generator, and it's going to go through and pick a random number, and it's going to be the same every time we run it if we use the same seed. If we change the seed, then it's going to be a different number right there. Sequence right there. So here they're showing with, if you look at the first one, they use the seed 67. So then they use the seed 867. That's a different sequence. But when we repeat the same seed, we get the same sequence every time. Right there. So we can have a repeatable random number sequence by using the seed function right there. So again, the function is sseed right there, or srand, excuse me, sseed, srand, and we pass it through. So in order to get a different seed each time that we don't have to worry about entering the seed, we normally would use the time function right there. So we pass it the function time, And that produced number of seconds that have passed since midnight 1 January 1, 2070. So it's a semi-random number right there. It's going to be different every time we run the program. So normally we would just stick in our program that line right there. If we get here, you'll see here, this is a program, and this is one that I'll talk about next time. It's called the Game of Craps. It's a game that you'll find at casinos. They throw the dice. You know, it's one you see in all the movies where the guy's throwing the dice, and they've got, you know, people betting on various things and that there. That's called, the game's called Craps. That's there, but it's got certain rules, and this is actually kind of an interesting program. One of the things I've always done is I've always made my students in the States do this program simply because it's interesting. If you play 1,000 games of craps or 100,000 games of craps, you'll find that the number of wins is somewhere just less than 50%. But it's always less than 50%. That's there. And that gets us to something in gambling terms, or statistical terms. It's not just gambling, but there's something called the law of large numbers. So if you have a random event that has a probability attached to it. So in other words, if I have a probability, for example, of throwing the dice, it's 1 through 6 right here. You know, 1, 2. That's a fairly uniform probability. But if I throw 2 dice, I've got 2 to 12 right there. And you'll find that it's something like this right here. It's, you know, I mean, it's more of a square function because there's discrete values up there. But the number 7 is the most common. Because if you look at the number of possibilities of getting a 7, you could get a 1 and a 6, you could get a 2 and a 5, you can get a 5 and a 2, you can get a 3 and a 4, you can get a 4 and a 3 right there. There's 5 different ways of getting a 7. There's only one way of getting a 2, and that's to get a 1 and a 1. There's only one way of getting a 12, and that's to get a 6 and a 6. There's only 2 ways of getting a 3, and that's a 1 and a 2 or a 2 and a 3. That's there. So we have that there. So when we look at, if we throw 3 dice, we might get a 2, 3, and a 5. But if I throw 1,000 dice, I'm going to get a lot more 7s than I am 2s and 12s. Because the more throws of dice, the closer the odds are, the closer the numbers match the actual probability right there. And as it turns out, in the game of craps, the more games we play, the closer our winnings get to the probability of winnings. That's why, one of the things I quit doing after I took my first course in statistics, and that was ever going to a casino and expecting to win. You know that the longer you play the one-arm bandit or the slot machines, the closer your winnings are going to match the programmed probability of winning that this machine's programmed to give. Slot machines are programmed to put out, we'll say, 70% of the money put in is given back out, 30% is kept. So your odds of winning are going to be less than 50%. And the reason it's going to be less than 50% is that the casino has to make money. Now, granted, somebody can walk into a casino and put one ringgit or 50 cents into a slot machine or whatever and pull the arm and win money. But if they keep putting the money in, eventually they're going to walk out with no money. Gambling will never pay if you gamble enough. It just doesn't pay. And that's why I've always used this I'm an anti-gambling person, and I don't talk about why gambling's wrong from a religious standpoint when I'm talking in the U.S. to most of my students were non-Muslim. I would show them with statistical software programs. We're going to play craps and we're going to throw the dice so many times, and you're always going to put your money on, black. And black pays out a certain amount. How much money do you expect to get at the end of 1,000 games of throwing the dice? Same thing with slot machines. You put the money in and this is kind of interesting. And again, what's funny is you'll see that as you play this game, the odds are close to 50%, but not quite 50%. And you want them to be close to 50%. Otherwise, people think that they're always, that they're not necessarily losing. They keep putting money in. If the odds were a winning was only 10%, people would give up, quit playing right away. So, casinos are set that there. I'm going to quit.